Let's begin with Java utility package. The Java utility package contains a variety of utility classes, including collection framework, legacy collection classes, event model, datetime, internationalization, and various other utility classes such as string utility, zip and jar utility, and so on. In this unit, I would majorly focus on collection framework, string tokenizer, and date and time. Now let's begin with the collection framework. A Java collection is a collection of objects. The Java collection framework is also called as a Java data structure. The framework includes stacks, queues, linked lists, maps, and so on. A collection. A collection, as the name implies, is a group of objects treated as a single entity. We have already been working with group of objects in the form of an array. Then what is the difference between an array and a collection? An array may represent a collection of objects, but then its size with respect to the number of elements it can hold is static. For example, imagine an enquiry counter at a railway reservation center. And I wanted to make a list of all people who visit the enquiry counter. In such a case, what should be the length of my array? The length of an array may not be predictable. Now let's assume I have declared an array of 1000 elements. But only 500 people visited the enquiry counter that day, which implies I had wasted the memory of 500 elements. Therefore, I downsized my array length to 600 elements the next day. But then on this day I had 1200 customers, and so my application was unable to hold the remaining 600 customers. This problem could be solved if we can have a framework which can dynamically change its size to accommodate the needs. This is what exactly collection framework does for you. A collection framework is a unified architecture for representing and manipulating these collections. The collection framework. The collection framework is made of the interfaces and their implementations. Interfaces can be considered as a contract upon implementing which a class agrees to become a certain specific collection type such as linked list, stack, queue, tree, and so on. Implementations are the concrete implementations of the interfaces. Implementations can also be treated as reusable data structures. Implementations are the algorithms or methods that perform the manipulations on these collections. The collection framework has 7 core interfaces, with collection interface at the root of collection hierarchy. The collection interface defines the generic methods that are extended by all other collection interfaces, like set, list, queue. The set interface defines additional methods required for set operations. All classes implementing the set interface provide the unique collection objects. The queue interface. The queue interface provides the additional methods for queue operations, that is, first in, first out. This implies that the first object added to a queue collection needs to be removed first. And similarly, the list interface. The list interface defines the methods required for list operations, such as linked list. Further, we have the map interface. Map interface defines methods to deal with map operations. The classes implementing the map interface provide the functionality to deal with key and value pairs, where key is a unique identification of a value object. There are other utility interfaces such as comparator, iterator, enumerator, and so on with the collection framework. Now let's understand when to use each of these interfaces. Imagine you're working in a banking domain processing loan requests. While doing so, you have noticed that a few customers have raised the same loan request more than once. And as the number of requests is huge, it's not possible for you to manually sort out this data. This is the right situation for you to use a set. The set eliminates the duplicate requests and forms a unique set of loan requests. Now let's say that the customers are constantly calling to find out the status of their loan requests, and you're finding it difficult to find the requested data. In such a case, it would be a good idea to use a sorted set. A sorted set not only eliminates the duplicate values but also sorts them in the desired order. Now let's assume you have been asked to develop an application on railway reservation system. In a reservation system, you can imagine multiple requests coming on the same train at the same time. In such a case, you would have to queue the request before processing the same. This is one of the situations where you would have to use a queue interface. Let's also consider that a few customers might want to cancel their request even before they have been processed. This means that you will have to remove them from the queue. That is, from a specified index position of the queue. And if you also had to implement a priority queue and had to add elements in a specified index position of the collection, then a list would have been a more appropriate choice. In a list, you add or remove elements from desired index positions. When would you use a map? A map, as discussed, is a collection of key and value pairs, where key represents a unique element mapped to a value object. Let's imagine an examination reservation system. At first, my client had to collect the examination fee from the students in the first come first served basis. That is a queue order. Having processed the examination request, my client has to distribute the hall tickets. We all know that it's not necessary for the student to come in the same order to collect the hall tickets. So I suggested my client to provide the student a registration ID at the time of collecting the examination fee, and then later map the hall ticket to the registration ID. This means that as and when a student comes back to my client to collect their hall ticket, they would produce him the registration ID, using which he would be able to provide the hall ticket. Here registration ID acts as a key and hall ticket as a value in a map. Further, one can also go for a sorted map where the keys are sorted in the desired order. Now let's look at the core collection interfaces in a little more detail. Collection, as discussed, is the root of collection hierarchy. Collection is the most generic interface for maintaining collections. It's not directly implemented by any class. List interface. The list interface extends the collection interface. The list interface maintains a sequence of elements. The order of adding elements to a list is maintained. List user has precise control over the elements by their indexes. This means that the list user may add, remove, or manipulate an element at a given index position. Unlike sets, lists can contain duplicate elements. List interface is implemented by the classes such as ArrayList, Vector, and Linked List. Here are a few important methods of the list interface. Boolean add adds an object to the end of the list. Void add int index and object adds an object at the index position specified. Void clear empties the list. Object get index returns an object at the specified index. Is empty returns true if the list is empty or else returns false. Object remove index removes the object at index position. Boolean remove object removes the first occurrence of the specified object in the list. Set index and element replaces the object at specified index, returns the object previously at specified position. Int size returns the number of elements in the list. ToArray returns the array of all the elements in the current order. Map interface does not extend collection interface, as discussed in the previous slides. Map interface maps keys to value objects. Each key in a map interface is unique. Each key in a map interface can at most map to one value object. This interface is implemented by hashMap, hashtable, and linked hashMap classes. Sorted map maintains keys in a sorted order. Sorted map is extended from map interface. The sorted map is implemented by tree map. Important methods of map interface. Get returns the value object associated with a given key object. Put associates the specified value object with the given key. If the map previously contains the key value, it replaces the new value, returning the previously associated value. Remove removes the mapping for the given key. It returns the value object associated with the key. It, however, returns null if the key was not found. Hash code returns the hash code value for this map. The hash code value of a map is defined to be the sum of the hash codes of each entry in the map's entry set. Contains key returns true if this map contains mapping for the specified key. Contains value. Returns true if the map contains one or more keys mapped to the specified value. Values. Returns collection view of the value containing this map. Set interface. Set interface models the mathematical set. Set interface cannot have duplicate elements. Set interface is implemented by hash set and linked hash set. Sorted set. Sorted set extends the set interface. Sorted set contains elements in ascending order. Sorted set is implemented by tree set. Here are a few important methods of set and sorted set. Boolean add returns true if the specified object was not already present, else returns false. Void clear removes all objects from a given set. Boolean contains returns true if the specified object is present in a given set. Iterator returns the iterator object associated with this set. An iterator object generates a series of objects one at a time. In addition, it also provides methods to remove objects. Remove removes the object specified. Returns false if the object specified was not present as a part of the set. Comparator returns the comparator associated with the current sorted set. We will soon see how a comparator actually works. Head set returns the set of elements whose index is less than the target. Tail set returns the sorted set of elements whose index is greater than the source element. Subset returns the set of elements between the source and target elements. Let's talk about the comparator interface. The comparator interface is implemented by all elements of sorted set and sorted map. By default, the comparator defines the natural order of the object class, which is based on the ASCII or the number values. The method compareTo should be overridden in order to implement custom sorting. Now let's look at an example. In this example, I am intending to create a set of student objects, sorting them on the name of the student. Here is my student class. In this class, I have two data members, student ID and student name. I had implemented the property methods of get and set. Get student ID, get student name, set student ID and set student name. Further, I have also overridden the toString method. In order to implement the custom sorting, I had implemented the comparator interface to the student comparator class. Further, I have overridden the compare method. I had obtained the student1 object from the object1 and then the student2 from object2. Further, I have extracted the student name 1 and student name 2 by calling the getStudentName methods. And then I had called the student name 1 dot compare to student name 2. The compare to method of the string class returns the ASCII difference. This enables the student comparator to sort the student elements on the name of the student. Now let's look at the main class. At line 7, I have created an object of a tree set. Tree set student set is equal to new tree set, passing the reference of a student comparator. Further, from line 8 to line 11, I am adding student elements. As and when I add a student element, it would internally call the student comparator object's compare method and then sort the student elements in the student name order. One additional thing that you would notice here is the element added at line 11 is not included as a part of the set, as Tom is a name added to the set already. Now let's look at the output. Here is the output in a sorted order: John, Jim, and Tom. Enumeration. Having created a collection, you would like to traverse it. An enumeration object generates a series of elements one at a time. Methods of an enumeration object. Has more elements. Returns true, indicating that more elements are available in the series, or else it returns false. Next element. Successive calls to next element return successive elements of the series. Iterators. Like enumerations, iterators also generate a series of objects from a given collection. Methods of an iterator. Has next. Similar to the method has more elements, returns true, indicating that the iterator has more elements to traverse. Next. The method next returns an object from the collection. In addition to enumerations, iterators have a method remove. It removes the last element returned by the iterator. Let's look at an example. In this example, I have created a set item set, as you see here at line 7. And then I added the items from the string array to the item set, calling the add method, as you see at line 8 and 9. And then I extracted the iterator object from the item set by calling the iterator method. And then I have the while condition checking for has next, and further printing the items. As discussed, has next returns true or false, indicating the number of elements available in a set. And then next returns the object from the current set. Here are the important classes that implement the collection framework. In this table, you can see the three interfaces: set, list, and map. The set interface is implemented by HashSet using the hashing algorithm and TreeSet using the balanced tree algorithm. List is implemented by ArrayList, which is a resizable array. An implementation of ArrayList is not synchronized and therefore recommended for non-thread safe operations. Linked list also implements the list interface. It implements all algorithms of a linked list data structure, like add elements at a specified index or remove element from a specified index, and so on. Further, the map interface is implemented by the hash map and tree map. As discussed, a map enables you to map a given key object to a given value object, where key object refers to a unique object. A balanced tree is formed on the key objects of the tree map. We have just seen the classes which implement the core collection framework. The classes which implement the core collection framework must provide two constructors. One, a default constructor or a no argument constructor which creates an empty collection. And then a constructor which takes a collection as an argument and creates a new collection with the same elements as specified in the collection. This is typically required in a case where you already have a collection and you want to add to the same collection. The collection framework algorithms. The algorithms provided by the collection framework are reusable pieces of functionality. This implies that the same classes can be reused in multiple projects, helping in reducing the development time. These algorithms are static and come from the collection classes. The polymorphic nature of the algorithms enables their operations on variety of classes, implementing a common interface. For example, a collection can be implemented as a synchronized list such as vector or a non-synchronized list like an array list, or implemented as a set such as tree set or hash set, as discussed in the previous slides. The collection framework algorithms enable you to perform various operations such as sorting, searching, shuffling the data, manipulating the data using the methods such as reverse, fill, copy, swap, add all, and also finding the extreme values such as minimum and maximum values in a collection. Now let's discuss about the important classes of Java collection framework. Now let's talk about the class ArrayList. An ArrayList is a resizable array implementation of a list. Now when would one need to use a resizable array? Let's consider a railway reservation inquiry counter. Now let's say you have been asked to collect the information of the customers inquiring for a given train. Typically, you may not be in a position to predict the number of people who might inquire about the given train. If you consider creating a static array for such kind of a requirement, you might end up falling short of elements to hold the data or maybe end up wasting your memory. In such a situation, if you have chosen to go for a dynamically resizable array such as an array list, you would neither waste nor fall short of elements. ArrayList supports random access of its elements. Any element can be accessed in constant time, given only the index of the element. array list can hold only objects. However, autoboxing is a technique used to make you feel that array list also holds primitive types such as int, long, double, boolean, float, and so on. Constructors of array list. Array list comes with three constructors, a parameterless constructor and a parameterized constructor which takes a collection as an argument, and also a constructor which has an initial size. Let's look at a few examples. Here is the example of an array list. In this example, I am creating an object of array list at line 6 using a parameterless constructor. The parameterless constructor initializes the array list to an initial capacity of 10. Further, I am adding some integer values to the array list object using the add method. The method adds the elements to the end of the list. And further, I am using the other add method which takes an argument of the index position, adding the element at a specified index. ArrayList provides me a method size which returns the current size of the array list. Further, from line 15, I am extracting the value from the array list and printing the same. In order to extract the value from an array list, you can use the get method. Get method takes the index position. Get returns the element at the specified index. Now let's run this program. Here is the output. At index 0, we have inserted a value 1. And at index 4, we have inserted a string value 5. Here is a statement which inserted the string value 5. Vector class. Vector is similar to ArrayList. However, it is thread safe and its methods are synchronized. It is advisable to use vector objects only when we are dealing with multi-threaded applications. For example, if I have a collection which is used by more than one threads and I intend to keep the collection thread safe, then I can create the collection as a vector. Vectors are a little slower as compared to ArrayList. It is so because vector methods enter and exit thread monitors for every method invocation. Or in other words, I can say that ArrayList methods are not synchronized. On the other hand, the vector methods are synchronized. The various operations carried on vectors being synchronized are relatively slower in comparison to an array list. A vector optimizes storage management by maintaining capacity and capacity increment. That is, the vector automatically manages the capacity by incrementing or decrementing the capacity depending on the elements added or removed from the vector objects. Vector constructors. Vector comes with 4 constructors with one parameterless constructor where the initial capacity is initialized to 10, and then a vector with a collection object as parameter. Here a given collection can be initialized or converted to a vector. Then a constructor with an initial capacity where the initial capacity can be passed by the programmer, and then another constructor which comes with the initial capacity and also the capacity increment. That is, if the initial capacity is full, then what should be the incrementation done to the capacity. Now let's look at an example. Here is an example of a vector. This example is very much similar to the previous example that we have seen on an array list. Instead, I had replaced the array list with a vector. In this example, I am creating an object of a vector at line 6 and then adding elements to the vector object, provided the index is not equal to 5. Further, I have added the element 5 at index 4, which is the 5th element. And then we extracted the size and also printed the same as we have done in the previous example. Now let's run this program. If you notice here, there is no change in the output of this example. It is almost the same as what you have seen in the previous example. Therefore, I conclude saying that vectors are similar to array list but then are thread safe. This implies that vectors are required to be used when you want to make a given collection thread safe.